Hey friends, how are you today? We are going to talk a little bit about water and how neat water really is. Now, last week we had snow and we used that polymer and put water in it, and we saw a physical change in the polymer. Well, let me tell you that water is one of those cool things that can physically change just because of temperature. And temperature is how warm or how cold it is. And we're going to talk a little bit about how water can change when it gets hot and how water can change when it gets cold. And then we're going to do a very fun experiment with ice that you get to play with all day long. So, water's awesome, right? We need water to live. Humans need water, animals need water, our world needs water, because without water, we wouldn't have plants, we wouldn't have lakes, we wouldn't have rivers, we wouldn't be able to hydrate our bodies when we're thirsty. So water is super, super important. And usually when we see water, it's in its liquid state. That means it is movable and all that. Now, when you heat water up, something magical happens to the water. It produces what's called steam or water vapor. And even though it changes into like a steam or water vapor, it's still water. It's still the same thing. So like I have my really hot cup of tea right here, and I can see steam coming off, and you might not be able to see that on the camera, but I'm going to show you how you can see it. We're going to take this clear cup right here. See, there's nothing in it. We're going to set it over top of my hot tea and watch what happens to the plastic cup. It's not so see-through anymore, is it? Do you see what's happening inside? The steam from my hot tea is raising up into the cup, and it's forming condensation on the inside. Now, here's the interesting thing. It doesn't look like water, but guess what? It is still water, because when we touch water, what does it feel like? It feels wet, right? Well, look at the steam in here. When I touch it, it still feels wet. And I know that you can see water vapor in your house. Like maybe when you take a bath, your bath is so warm that the mirror in your bathroom gets all foggy. That's water vapor that's turned into steam and condensed right on your mirror. So water can be liquid, but it also can be a gas or a vapor, just like this. Isn't that the coolest thing? So that's what happens when water gets hot. It produces steam or water vapor and creates condensation on things. But what happens when water gets cold? Like we're talking really, really cold, like below freezing temperatures, like below 32 degrees. What happens to water? Do you know? Yeah, you're right. It turns to ice. And look at this. I took water and I froze it in my freezer, and now it's a solid piece of ice. Look at that. This is still water. And when it melts, it's going to go back to water. Just like when the steam gets on makes condensation on like the outside of the cup, it still turns back to water. So even though it's physically changing, it's still the same thing. But this water, it's hard. And oh my gosh, it's cold. And I noticed that when I put my warm hands on it, look what's happening. It's turning back to water. So that's the really cool thing about water. Water is science, and it can physically change itself into water vapor, into liquid like running water, or into ice, just depending on the temperature. So you're probably wondering, why do I have all of these things frozen inside of my ice? Well, this is what I want you to do at home. I want you to freeze some Lego toys or some dice or some fun things in ice. And then you are going to watch how the ice can transform back into water over time. And you're going to excavate, which means to remove those things that are trapped inside the ice. Because look, I can't even touch these right now. I can touch the ball because I kind of left it sticking out a little bit. But the dice, look at that. My fingers cannot even touch it. How am I going to get it out of here? Well, let's see what happens when we start to do things to this ice. To do this fun ice excavation at home, you're going to need a few things, and everything I pretty much provided for you except for the toys and the container to freeze your water in. So what you're going to do is 24 hours before you do this experiment, you need to freeze a container of water with some fun little things inside of it. Now I put some dice and a rock and a shell and a ball in mine. Okay, you're gonna need your silver tray. So this is what you're gonna do to put the ice in, just like that, so it doesn't run all over your table. And if you don't have that with you, any rimmed pan will work just perfectly. Okay, the other thing that you're gonna need is, I gave you some chopsticks inside your bag. And these are gonna be for poking at the ice and chiseling it out. Or if you have a wooden hammer at home, you can also use that, or maybe any other tools you might find in your house. You're going to need your cup filled with water and your little pipette thing. And as you can see, my water is blue. And I did it blue so that when I do the experiment, you'll be able to see it a little bit better. I just use food coloring, and you can do this too. It just kind of gives you a little bit more visual experience, but you don't have to have colored water. You can just use plain water. And your little pipette thing is this little plastic tube. And this thing sucks up water. And let me show you how it works, because that's the tricky part about pipettes. What you have to do is you have to squeeze it. So you squeeze it tight at that little bulb at the top. And then you stick it in the water, and then you let it go. And what happens is it sucks up the water, and it's stuck in there. And until you squeeze it again, it won't come out. So squeeze, put it in the water, let it go, pull it out, and then squeeze it wherever you want it to go. And you should probably just make sure you either squeeze it back into the cup or onto your ice tray, okay? Sounds good. The last thing that you'll need is some salt. Now, salt is something you might have in your cupboard. And here's the interesting thing. Salt has a very interesting reaction with ice. So when you use the salt, you're just going to want to use a little bit of time. You don't want to dump the whole thing on there, but you can sprinkle it on and see how the ice changes when you sprinkle it with salt. Okay, let's get started. So when you are a scientist and you're doing experiments, you want to make sure that you have all the stuff that you need right here. And so here are all my things that I needed. And I've already put my ice inside the pan. And what I've noticed already is, because my house is warm, the ice is already changing and it's melting. And look at, it's creating a puddle in my pan. Now, if your puddle in your pan gets too big, you want to make sure that you dump it out so that it doesn't overflow. But, you know, when I'm touching the ice, I'm feeling it, and it feels like cold and hard. And because my hands are warm, they're getting wet because the ice is melting when I touch it. So that means I might need a towel. So I'm going to grab a towel really quick. Luckily, I had one super duper close. So what I can see about the ice, here's other things I can see. I can see that some of the ice is white and some of it is clear. And I see little bubbles in there, and I wonder why those bubbles got in there. That's really kind of interesting. I noticed that it's shiny. When I first took it out of the freezer, it wasn't shiny. It was kind of a dull color, but as it's warmed up, the water has made it shiny. So the stuff I have in there is like, it's in there. I don't think it's ready to come out. I mean, the ball's somewhat out. So what I'm gonna do is I'm gonna sprinkle a little bit of salt on top of this, and then I'm gonna come back. I'm gonna wait maybe like 10 or 15 minutes and see what happens, okay? So I'm gonna take a handful or fingerful of salt, and I'm just gonna sprinkle it right on top of my ice. You can do as much as you want. I just remember, just sprinkle it. Don't dump the whole thing on there because it won't have the same effect. And then, you know what? I'm gonna take a little bit of a break, and then I'm gonna come back in a little bit and see how this changes and see if I can get any of these items out of there. Okay, so it's been about 15 minutes and I put the salt on top of it. And wow, I am shocked at how much my ice has transformed. And it may not be super visible to you, but the entire top of my ice has become very rough and it looks very different. And when I touch it, I can feel that like the salt did something to this surface. I wonder what it does. And I'm interested to hear what you think that the salt did to this. But I'm gonna put a little bit of water on here and see and show you what the difference looks like. Because before it was just smooth and soft, and now it looks completely different. Let's take a look at it. Maybe you can see, and I'll hold it up. And maybe I need to do a little bit more food coloring in here. But as you can see, the surface has really become full of little crevices, and the blue water is sinking down into them. So I'm wondering if that's gonna make it a little bit easier for me to try to get something out. I'm gonna try. I'm gonna use my chopsticks. Oh, yeah, it feels like it might make it easier. Oh, and I've noticed that it's the salt really melted the ice around this ball. So I have to work on this and see if I can get it out. And look at all the water that's in my pan now. So, salt does something to ice. And I'm wondering if you can guess what salt does to ice. I'm not gonna give you the answer because I want you to think about it. It's kind of like what hot air does to the ice. It does something that creates a puddle of water. So I'm gonna leave it for a little bit longer, add a little more salt and see what happens. I couldn't get that ball out. I don't think my dice are ready to come out, although this one is starting to show in the back a little bit. Can you see that? It's melted enough where it's getting close to coming out. Ooh, and I can feel the edge of the shell. So what I'm seeing is that even though I put the salt on the top, the melt is affecting the bottom of it too, because the water's going around it and melting. Okay, ooh, things are starting to happen. I'm gonna flip it over and I'm gonna put salt on this side and see what happens on this side. So I let my ice sit a little bit longer, and the rock is so close to being able to come out, and so are the dice, and I decided I was gonna use my hands on it a little bit, and now it's kind of cold, but my warm hands are warming it up. And I thought, well, I wonder what would happen if maybe I poured a little bit of the water on. Not the whole thing, but I was gonna just pour it and watch how it moved through the crevices. Look at how it moves through there. And you can see that it's made some holes that go, I don't know if you can see this or not, but they go all the way through to the other side of the ice. I think that was really cool. Like there's a hole right here that if I took apart my chopsticks, I think I could poke a hole all the way through. I'm gonna try. Oh, I did. Look, it went through all the way to the back of the ice. So the salt has made holes in it and just created a lot of interesting things. I can see that. I can almost see that rock on the other side. It's pretty cool. So I'm gonna stop my video here because I want you to have fun and experiment with this project. Remember, have a towel close by. Make sure you cover up any surfaces that you need to, but have lots of fun. And I want to hear from you how your ice experiment worked. Did it all melt really fast? Did it melt slow? Did the salt change it? Did pouring the water on it change it? How did it feel? How did it look? Did it smell like anything? When you took the ice out of the freezer, did it make noises? These are all the things that I want you to tell me about. So when you're done with your experiment, send me a video and let me know how your experiment turned out. I hope you all have a wonderful day. Stay cool. Bye.